So today we're going to look at the atmospheric concentration of greenhouse gases, and particularly in this case, we're looking at carbon dioxide, which is the most important one emitted by human activities. And the first thing is, if we're looking at a graph from 1960, you notice it starts actually in 1959. That's when we first started measuring this systematically. Where would you go in the world to get systematic measurements of carbon dioxide that wouldn't change real specifically by being near some source, but really a nice mixed area? So that was asked back in the late 50s, and what solution emerged was to put it on top of Mauna Loa, the mountain in Hawaii, way up high. And so there's no nearby industrial source. So by the time you get uh, carbon dioxide swirls around the world and the winds and so on, that's a pretty good measure. So, but the point here of this slide beyond that, besides, hey, how do we measure this, is that there is a trend here, and that trend is up, 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 up. And that's going to be the focus, in fact, for quite a bit of this unit for exam 3, is understanding that and also looking at another impact of that later on. So the first thing is it's been going up inexorably, and we've gone from 277 parts per million, if you look at the top there, to 470 parts. We're now I don't remember the exact number now, but it's every year it gets a little higher. And as you can see, it fluctuates a little bit with temperature. Northern hemisphere gets is where the photosynthesis is the biggest thing in the world, and so when we were having a lot of that, we have a little reduction, and then it goes back up again. So there's a little seasonal change there. So this is a diagram of the anthropogenic, meaning human generated, part of the global carbon cycle. So our combustion of fossil fuels is the big story at 35 gigatons carbon dioxide per year. You think about gigabytes, you can think about gigatons. The land use change is another one. And so deforestation, for example, is part of this story, much of it. And you might be a little confused if you remember the all causes of the climate warming dynamic graph we looked at last time. Wasn't land use showing a negative? And the answer is yes, because it looked at all effects. This is just the carbon dioxide itself, which does have a warming effect. But there's also been an increase in albedo, global albedo, because of deforestation. So we're reflecting more sunlight back because of that. So that effect is negative. So the balance between the two in the end is what we saw in that other graph. But this is just carbon dioxide itself from deforestation, from clearing of bogs, swamps, taking grasslands and putting them into cultivation, these sorts of things. So that's a big one. The biosphere is a net recipient due to greenhouse gas emissions. Some of that is that fertilizers make plants grow more and take in more carbon dioxide. There's also some other parts of that, but that's the main thing. And then what we have, as well as the ocean being a sink, and so you can sink, meaning that the arrow goes down. And there's some interesting things happening. The stocks, as I'm looking over on the right here, the stocks, I think it's a circle, is the amount. So there's a lot of carbon in the oceans that's stored, that's inorganic, it's dissolved, versus organic, which would have carbon in it. The surface sediments have some. The soils have quite a. We're going to turn to that in the very last unit. And permafrost also has some in the Arctic regions and some high mountain areas. You can see that there's really not all that much carbon in the gas reserves, oil reserves, and coal reserves. By the way, gas means natural gas, not gasoline, as compared with some of these other sources. Even just surface sediments have more, and soils have more carbon. But still, it's a huge amount, and yes, we're combusting it. So not only is the total amount in the atmosphere more, but you would imagine that our human-caused emissions are rising every year, pretty much, with a few exceptions. So this is just a graph since 1990 that shows that. There is a bit of a leveling off that we've seen since 2010. Some of that was related to the Great Recession in some countries, and some of it was related to some reductions in the acceleration of the use of coal plants. We'll get to that in a bit. But the real sharp increase was during China's expansion in their industrial economy in the 2000s, about 3% a year. The top emitters globally, if you just take the most emissions from the countries that emit the most, rather, China is kind of the big story now. But that wasn't always the case. It wasn't that long ago, about when many of you were born. China was actually number 3 in these groups. There's the US here. This is the 28 countries of the European Union here. So collectively, that's their story. And you can see they've been reducing emissions while China has been growing theirs. Now, remember, China started out very, very poor back here. And it still is a country that the living standard roughly about like Mexico. So now it's middle income. But much of this is actually, and we'll come to later, is emissions due to making things for other societies, including the Europeans and us here in North America. You can also see some of the other countries here at the bottom. But remember, these are total emissions. It doesn't account for how many people there are. So to understand the kind of role of each person on average, we could look at this. And each person, as you can see, of all the major emitting countries, is a big number for the United States. We are at almost 17 tons per person in 2018. By the way, that's the British spelling, if you wondered that. And Japan, the EU, and so on. This is what's interesting. Well, China looked really big on that last graph. We're really on a per capita basis. Their emissions aren't nearly so high, less than half of ours. India, one of the world's most populated countries as well, over 1.3 billion people, roughly that of China, just a little less, comes in even less in terms of total emissions. So it's still an economy that has a very, very large number of people who are just barely participating in modern life. Now, if you look at per capita, then it gives a bigger sense of sort of the living standards a little bit in each country. But it misses the kind of, okay, which countries are some of the biggest causes. Now, what do we actually do with all of this fossil fuel combustion? And again, the fossil fuels are coal, oil, and natural gas. Electricity and heat, industry, transport are the big 3. And this includes heating buildings, homes, and everything that we do with electricity for our uses. And so if you were going to try to reduce the carbon dioxide emissions, the sort of obvious places to look might be here and here and here. Now, we're going to kind of ignore industry because that discussion is incredibly complex, but we are going to look later in this unit, not on this particular YouTube, but later. We're going to look at electricity quite a bit, and we're going to look at transport as well. Getting things around us, personal transportation, trucks, trains, aircraft, ships, and so on. All right. Now, the major commodities. That's how, probably the easiest way to think about it for a lot of people. Okay, what do we have? Coal, oil, gas, and so on. Okay. And they put cement as a separate factor. Cement is made using energy, so it's kind of a strange place to put it, but it's such a big number overall. People are always surprised that it's such a big number. It's about 4% of global emissions. Coal is the number 1 producer of emissions of carbon dioxide. Oil is second, as you can see, and natural gas is third. And in fact, they're all going up pretty much until real recently. At least coal has kind of leveled off now from falling in the United States to maybe leveling off in China. So coal, oil, natural gas, those are the big stories. And all of them, until very, very recently, the last decade, have been increasing. Coal could start increasing again, by the way. Not entirely clear what will happen with that. but it's also the one that puts the most carbon dioxide in for the given amount of energy utilized. So it's a very inefficient way in terms of carbon dioxide emissions to energize an economy. Mostly coal is used to make electricity, by the way, whereas most of oil is used in transportation. That's its biggest use, rather. All right. So a few other things. If you think about China as the factory of the world, and increasingly that is the case, they're not quite half of all the production of the world, but it's a big number. If you just talk about what the Chinese people themselves and the carbon emissions associated with their own consumption, their number would be at this bottom of this dotted line here. But if you look at the territorial, this is the total amount within the Chinese national territory. So for their own consumption, it's less. In other words, a lot of Chinese emissions are just making things so that other people can use them. Us, the U.S., and the European Union would be two primary examples of that. So our emissions, if you do it this way, are even higher than they otherwise would be using this for just things that are made, okay? Things that are made, consumption. Now, there are other ways we use energy too. And so that's why the numbers here aren't the same as the one in the total graphs earlier, okay? So again, main point is that the net receiving countries of these industrial made goods, like the U.S., like the European Union countries, have more total embodied, it's called embodied emissions associated with their lifestyle. So in other words, a big part of the rise of China's carbon dioxide emissions is the making of goods that other people consume. So in a sense that we're in it too. We're part of China's curve. That's what I wanted you to understand there. That said, you can see in this map how that looks globally, just drawing the arrows. Anything that's a blue color is a net transfer of carbon dioxide embodied emissions to, so these are receiving countries, so the European Union, us, parts of South America a little bit are net receivers, as well as Japan in that story too. And you can see the sending areas, the net exports, that's largely a story of China. And increasingly, some other parts of Southeast Asia are doing that as well. So that is sort of the flows of goods on that carbon dioxide story related to it. Okay, well, that's all for now. We'll get into what we can do about this next.